Yes, hello, well, good afternoon. My name is Jose Orellana, and I'm a solutions consultant for Lumivero. We are the developers of XLSTAT. Um, I've been a consultant for over 10 years, working in a lot of Excel modeling and well, with an engineering background. So that's me. Now, let me get started with XLSTAT. XLSTAT is an add-in to Excel that allows you to do a lot of, statistical analysis. It has over 270 features or functionalities or analysis that you can use. It works both in Windows and Mac version of Excel. I provide an in-app assistant that can help you, figure out what kind of analysis you need. Most of the analysis, you don't need to do any coding. But if you want to, you can create your own VBA macros that run the analysis. Okay, there's a shortcut to create your own coding. You can also create your own R codes or R subroutines and have XLSTAT run them. So even though you don't need any coding required, you can if you want to. Okay. Now it is used for 150,000 users all over the world. I'll show you all our online tutorials and help files. We also conduct regular webinars of different functionalities and applications. And the software can be customizable in 9 different languages. Now, some of our most popular features are here. We have, again, as I mentioned, over 270 features, and we try to divide it into silos, some related to descriptive statistics, looking at modes, normality test, continuous table, also a section on data visualization. So you get your data ready, you have a look at it, you do the analysis. Okay, data analysis, for example, with the principal component analysis, PCA, that's a very popular one. Data modeling, we have this large number of regressions, analysis of variance, etc., parametric tests, as well as machine learning modules. Okay, these are some of the most common analysis, and we'll be visiting some of them. I'll show you some of the functionality when we get into the examples. Now, because we have 270 different functionalities, we provide basically 8 different solutions. A basic one with about 100 different features that's geared towards university and students, and then you can move on to the next solution, Basic Plus, and then the next pack of solutions are geared to specific industries. Okay, so if you're into sensor metrics, for example, consumer product testing, if you're into biology or medicine, marketing, engineering with a quality module, forecasting. There are modules that contain additional analysis that are heavily used in those industries. And the last is the XLSTAT Premium that includes all 270 features. I'll show you later how you can find out where specific functions or analysis, where they're bundled. Now, but who uses XLSTAT? If you're a statistician and you work doing statistics, XLSTAT is for you. These are some of the top industries and top clients, or some of the clients that use XLSTAT. So what is food and beverages, with the sensor metrics analysis, consumer goods, cosmetics, automobile. A lot of universities use our products as well as consultants. Now, I just want to jump into some cases and spend more time actually using the software. And for this, I've created 3 cases of different industries. Okay, and they will work. In each case, we'll use multiple functionalities to do multiple analysis. The first case is analyzing the toothpaste effect on whiteness of teeth. So Fridolina is the head of R&D in a toothpaste manufacturing company, and her team have been creating 3 new formulations on a product with the aim of increasing the whiteness of teeth. Okay, they have already created trained a panel of evaluators and created, basically got their feedback. Now she needs to evaluate and communicate the findings from this testing to upper management, trying to pass in what recommendation, what of the 3 new formulations is more likely she recommends to be brought into production. Okay. Now for this, she's going to use the analysis of variance analysis and ANOVA with the pairwise comparisons to the existing product. Okay, so you can compare. Now I'll be using some plots and then I'll show you how to use ANOVA. If you later go into the presentation, I believe we're going to share the presentation PDFs. I put some snapshots on how to get there. Okay, but as of now, I'll just go ahead and open an Excel file. As I mentioned, XLSTAT will run into Excel. Okay, it doesn't have to be running all the time. You can shut it down. Okay, you can just close it and it will close. It doesn't have to be loaded all the time. Okay. Now, this is my data set for that whiteness, for the whiteness. I have my toothpaste and each evaluator gave me a value for it. Okay. Now, one thing that I guess XLSTAT allows you to do is prepare the data, handle it a little bit. For example, I want the data like this for my analysis. But if I have data like this, now you might say, okay, I want to copy. No, you probably spend a bit of time trying to massage it and make it look like that. There's a lot of analysis here, functionality that allow you to do transformation on the data before you use it, okay? For example, I could do, in this case, I want to do what's called data management. And I can say, okay, I want to, this is my data, okay? And I want to unstock it, okay? Basically do an unstock version. I just want, instead of being like that, I want to basically get it on as it looks in columns B and C. Okay. So group variable, now just go, and I want to place it here. And it has variable labels. Now, this window here is a very common functionality. It's a very common interface for XLSTAT. Okay. There'll be a lot of different buttons here. I can reset the dialog box. I can reset the data sets. I can, I'll show you the next 3 buttons when we get to the side. But what this will do is, sorry, I want to unstack it. A lot of times we'll give me a little window like that saying, okay, this is the data that we're going to work with. And it just converted that automatically into this layout. Okay, so imagine if you have a very large table, hundreds of rows or columns. This already saves you just a lot of time. You can also, a few more things you can do is anonymize data. For example, if you have to share it, or decide what to do with missing data. Now, the next thing I want to do is I want to do some visualization. Okay, and I say, okay, let me plot this, make sure the data looks, see how the data looks before I do any other analysis. Okay. And I can do, okay, I can do the plot, and I can decide what is my quantitative data. Okay. Now, again, here we have these buttons again. And let me just show you a few things. Here, we decide which direction the data go. In this case, I have my data in columns. So I say in green. I could also go in rows in case my data is on rows, so I don't have to not transpose my data to make it work. I could just go. I could also do my data selection by clicking with the mouse. Okay. Well, I can say, okay, select scan for any column names and list them here. So in this case, should list here. No, all the different bits and pieces, right? All the different column headings that finds in this page. Okay, so you can just pick whiteness. Now you can see also piece of toothpaste which is related to column H. So I'm just gonna go with this one. I could also do the subsamples. The subsample in this case is the toothpaste. Now I'm going to generate the report on a different worksheet. Okay. Now I can also send it to a different workbook or to a specific range that I pointed to. A lot of times, if you're in a very large report or a very large analysis, you can just select another sheet. It's probably the easiest way. Okay. Now you can select a few options. What outputs you want on my qualitative data. Quantitative data, I have a lot of different statistics that I can display. Just go with the defaults. Go. You can also say, okay, what charts I want to display. I want some box plots, scatter plots, scattergrams, and then a few, make them vertical instead of horizontal, and highlight any outliers. I can just click OK. Again, it will show me this. You can get rid of this, but I personally like seeing, make sure that it has what data is showing. 24 bits of information, 24 pieces. And here it is. It will produce a report. Now let me just expand this a bit. Now for each one of the toothpaste, give me statistics for each one of them, box plots for each one of them. Now I can see, and I can have a look if I had more data, probably a bit more information. Okay, we can see the mean, the distribution of them. Okay, so okay, I'm happy with it. It's very important. Every report that generate this way, you can either navigate the different parts of it with it. Okay, you can even export them to, for example, PowerPoint. Okay, and then you can select, okay, what do I want to export? I want to export these three things, and it will create PowerPoint of those 3 bits and pieces. Okay, now we paste it as images. So if you have a significant report, you can just export everything and then focus on creating your presentation. Okay, so I looked at this. I'm happy. There's no missing data. Now, what my next step is in doing an ANOVA distribution. Now, as you can see, there's a lot of different, menu items, and a lot of them have more and more functionality, more and more analysis. So it might be a bit complicated. No, not complicated, but tricky to remember where things are located. Okay. So we have this search functionality here. Okay, I can just type ANOVA, click enter or search, and the results will give me all the analyses that have the ANOVA or are related to ANOVA. Okay, so in this case, and I can just launch them from here. It would also keep tabs of any recent analysis that you've run. Now here under ANOVA, I can select now the data format is columns. I just select now what is my dependent variable. Okay. My dependent variable in this case is my whiteness. Now as you can see, I can just select the column. I don't need to select the exact range now from this row to this row. Okay. Now I can also select the explanatory variable. In this case, we're going to do the toothpaste. Okay. Now I have to tell it to have variable labels, otherwise it will assume this first row will be his data. Now, there's a lot of other, functionality that we can apply. And if once you're here and you want to find out more, you can always go into the help. We'll give you this, and then help documentation. And it's very complete. It will go through the mathematics, how it works, every items, and how it affects it. Okay. So there's a lot to read if you want to find out more of every analysis. But in this case, what I want to do is I'm not trying to create a model out of it. I'm just trying to see if I'm trying to see which one of these is the most different from toothpaste number 1. Okay. In that case, what I want to do is be able to do a contrast. Okay. or pairwise comparison. So when I compare using, we have a few models that are available. This one is Tucky and Dunnett for no other, just to apply some of them. You can apply as many as you want. Okay, and then no contrast. And as an output, I just got to do a few charts, confidence intervals, and so on. Now, these buttons here allow me to, one of them is save the settings. So if I like this setting and I want to keep it for future use, I could click here and save this as a text file. Okay, and then be able to reload it in a later time for a different file, for example. Okay. Another thing that I can do here in this function here is it will create the Visual Basic code that will run this analysis. Okay, you'll create this code here, okay, and you can then use that on your own macros. Okay, so all I have to do now is click OK, and it tells me, okay, I have this Y 24 values, X 24 values, and then just continue. Now, in this case, it will ask me, what is my control? Who am I comparing to? And I said, okay, my T1 is the one that's currently in the market, so I'm going to compare it to it. Again, this will be a lot of information because I'm producing a lot of items, correlations between the values, and then the goodness of fit statistics on that. Okay, something that you can see is R square, for example, is so you can explain the whiteness from the toothpaste and a few other items, so you can see. The interesting bit here that I'm interested in is comparing each toothpaste versus the first one. Okay, how likely it is, and it goes through all the math. And now, if you're a statistician, in this case, not Fridolina, the user will look at it, but she wants to be able to present it, okay, and explain this to upper management. Okay, what does this all mean? And now what we do is basically it will categorize, create groups for the different products. Say, okay, this T3 could be group A, T4 could be belongs to group A and B. So it's very similar to anything on A and very similar to this other group. A and B is just two groups. Okay. And this analysis is basically saying that T4 is very similar to T3 and toothpaste as well as toothpaste 2 and 1. So there's no significant difference between T4 and anybody. Okay. Now, similarly, it's the same on this other use the von variety analysis. Okay. Same idea. So what is all this different pairwise comparison, all this different Tucky and von variety are saying is the only one that's very different to T1 is T3. So toothpaste number 2, toothpaste number 4 are not significantly different to what you already have in the market. Yeah. And that's something that's what you should try to present to. The user will try to present to the upper management. Okay. Now, here it becomes a bit more, I guess, clear, and this is more used on trying to convert the information. Okay. Basically say, okay, T3, now you have these little letters here represent likeness. So you said T4 and T2 are very similar to T1. So the only one that's really different is T3. And if you're gonna develop this, will be that product. Okay, T3 product. Now we also have, since I have you here, it's a lot of information, these tables, and sometimes, it's not too big, but sometimes you want to highlight some bits, right? For example, there's some functionality here on quick tools, for example, where you can quickly color from the minimum to the maximum. Okay, and it will color whatever columns you have highlighted, whatever section you have highlighted. can go. Okay, just simplifies your work just a bit. Can make things a bit easier. Okay. We can also go now move to the top of the report or end of the report. As I mentioned, some reports. Now this report is 200 rows, and some of them could be quite significant. So let me go back to the presentation. And now we did that and that. Okay, in case you want to, we can share the Excel file and you can play with it. Now the second example I have is Zlatan. He's an engineer for a manufacturing company, and he received a large file of data containing values on a system. There's the inputs and the outputs measurements that were taken, but contains too many rows. Okay, and the large, no, it's too low to put into Excel and then have to select Excel. Okay, now he just wants to run a linear regression after he makes sure the data is okay, that there are no missing values, that outliers are taken care of, and so on. Okay. Now he's going to make use of the in-memory loading from XLSTAT, so we don't actually have to load data into Excel. Okay, and that's very key in this type of cases where you have too many rows. Excel has a limit of about 1.2 million rows. So if you have large number that makes the file too large and you already have it as a text file, then you don't need it to bring it into Excel. Okay. Let's do that. In this case, there's no data here. Okay, so I just have I'll switch to the open from file mode. Okay. Now the first thing I want to do, he wants to check the data. So I want to run some descriptive statistics. Yeah. Now by default, the other windows look like this, right? Do the data coming in column shape, and you select from the mouse, using the mouse. Or as we did before, we scan the headers of the columns. Okay. The next mode is opening a file. Okay. And then in this case, let's go and open the file. Like have a large file, and you select the delimiters, how is it separated, is it comma separated, tab separated. Does it have headings? I can go on options. Do I have to click the lines? And I can just preview. Click preview. See if the data is looking okay. Okay, this is my data. And it has variable labels. If it didn't, then it would look like this. In this case, yes, it has labels. So I have x11, x21, and then my y. I can click OK. I'll load that up. And then once I click here, it's now loaded. I just have to click the right variables for each one of my inputs. Okay. Now I'm doing descriptive statistics, so I want to describe all three columns. Okay, I can just select one or two. Okay, and they're quantitative, they're all numbers. I could also load categorical data, qualitative data, okay, and even group it by different columns. So this is a simple example for you, but it could be something a lot more complex. So click OK. And again, I could go through this and what I want to present, missing values, maybe. Okay, and any charts that I want to show. So let's have a look. Click OK. Okay, there we go, it's done. So here we have descriptive statistics, the three columns, so it's 10,300 values. Nothing was missing. I'll show you what we can do when we have missing data in the next analysis. And then a few things, mean, max, quartiles, all the data that I asked for, all the statistics that I asked for. And then we have some box plots, scattergrams, and then strip plots. In this case, 10,000. They're looks like very uniformly distributed, so not much in there. And then I guess percentile plots, theoretical based on it, I guess on a normal distribution. I guess an empirical. So nothing major, no big outliers sticking out. I could not. We have all sort of tests, and you can run an outlier detection test. For example, okay. Two different tests for outliers. Okay. But suppose Zlatan is quite happy with what he has. Now he just have to run the linear regression and see what is the relationship between all these three variables. Again, we're going to go back to, actually we don't have to go back to data, but we can do modeling data. Okay, linear regression. Again, I could go back and search it, or probably it's on my recent. Okay, yeah, here on my recent. Okay, you see it's here all the ones that I have used during the webinar. Got these past 4 months. Go linear regression. Okay. Again, it keeps the same setup, same mode of input. It already knows the file. Okay, if I click here, I can modify it, but the moment it keeps the same file you've been using. Then when I click there, it scans, picks a variable. Now, my dependent variable in this case is the y variable. Okay, and the quantitative, we have the 2x variables. Okay. Again, there's a lot of parameters that we can use on the linear regression and covariance, validation. If you have a valid, you can define your set between modeling and validation, and then have another set for predicting using this linear regression. Now, a lot of what I wanted to show you here is a lot of the analysis will have this tab missing data. Basically, where you tell it what you want it to do in case there's a missing number, like a wrong data, or it's blank, or not a number. Okay. And then there's a few things you can do. Okay, first, do not accept, basically abort the analysis. Remove the observation. So basically, there could be multiple y's, but in this case, remove the entire observation. So get rid of the row. Just ignore it, or estimate it. Okay. If you know the nature of your data, you can estimate it and take the mean of the column or the mode, or even the closest neighbor to that row. Okay. In this case, I have 10,000 data points, and actually didn't have any missing point. I just could ignore that point. Take this as an error. As an output, just a few things. I don't want to show me the residuals because I have 10,000. Give me a list of 10,000 residuals, which I'm trying to avoid, not to have a huge profile at the end. And not test. And then a few charts just for that. Click OK. Okay, so again, some statistics, how many were missing, maximum standard deviation, quite standard, correlation between the values. Okay, and then some goodness of fit statistics. Now we can see, if you're a statistician, all of this will make sense to you, but the most common indicators are square, because it tells you what percentage of the y values can be explained by the x value. So this is quite almost a perfect model, I guess, you can build out of the x and y. Okay, it explains 99.9% of the y. And then here we'll have, for example, the equation that builds the y from those two values. Okay, so just a linear combination of them, and then an independent value. So you can use that, and then it tells you, the significance of the different x values, the residuals, the plots of them, what the error margin. Okay. And then the plot of the y's versus the predicted y's using that expression. So it's got almost a perfect fit. Now, you can also do some, I guess, some analysis will show you an interpretation. Okay. And then here, this one is quite clear. Now, given the R-square, all the variability of y is explained by the x1 and x2. And again, we also calculate F statistics on the ANOVA table. Now, the significance, given the significant level, says that it is explainable. So it is a good model. Okay. Okay. So we've done this without loading here the 10,000 rows, right? So now that's only it's kept in memory as you work on this. Once you close the file, it doesn't get stored on the file, those 10,000 rows. Okay. So very it's practical when you have hundreds of thousands of data points that you don't want to using to have to copy paste into Excel, because we know when you have after a few dozen thousands, tens of thousands, Excel might get a bit sluggish, right? Just because of the refresh rate of all the cells. So. Now that is using large data sets. Again, I pasted here some snapshots from what I just showed you. Just to remind you if you want to go back to the examples and build them. Now, the other example I want to show you has to do with machine learning, okay, and some of the tools we have with machine learning, and get some supervised machine learning in this case. And in this case, Koze is a researcher in university. She's working in breast cancer, identifying breast cancer from samples, and they're taking a few measurements from tissues. Now, she is not an expert in machine learning, okay, so it's not sure which one or what approach to take, okay. So we're going to use a tool. It's called UC-Feed, and it basically takes the inputs, and it will run probably 5-6 different algorithms for machine learning. Okay. Out of those, we'll pick one to run, one or a couple to run. More specific, so we can change I guess meta parameters and a few things that we can do with machine learning algorithms. And here, data case 3. Now, this is the data that they have been learning. They've been practicing. They've been gathering. Okay, they have all these measurements, and then they have numbers, and then the actual analysis of the sample. I guess what they know. This is the class. Okay, so we're looking at a machine learning classification model that we want to do. So it's either benign, malignant. Now, she then has some examples that haven't been categorized, and she wants to know if you can predict, okay, the classification based on just the physical measurements of the cells. That's what her team has been working on. Now, I'm going to show you, we're going to run EasyFit. In this case, we're going to advanced features. It's under AI modules here. We have here EasyFit. EasyFit again. It's very similar, slightly different interface. But here we have the Y variable to predict is qualitative, right? In this case, it's benign malignant. Okay, so it's a category, it's not a number. Okay. And the explanatory variables, we can take any quantitative, are they numbers, or they're just categories, or a combination of both. Okay. In this case, we see they're all numbers, right? They're quantities. So we're gonna come here, select them all. Okay, just the columns. It knows. No, it basically goes until it runs out of data. Okay, I want to display the results where put a new worksheet. I could also display a new workbook or point where I want it written. I like new worksheets, and it's gonna be called my easy fits. I could also select a few, what algorithms I want to apply. Okay, I'm just gonna go leave all of them. KNN, random forest, vector, and then also runs a descriptive analysis. And click OK. As you see, there's not a lot of parameters that I can play with. This is just basically a very high level, first run of all of them. So you get an idea which ones would not work. It's probably easier to say that which ones will work. Now it's done. Let's try already all those algorithms. I could detect the missing data. I remove 2 observations. Okay. And then we have a few statistics on the training data, the data that was on the left. Okay. And says, okay, this is the observations, statistics, Bellignant. I guess you can call this accounts for each one of them. And then it says, okay, trained in all these modules, all these models, and found that probably SVM had the lowest number of misclassifications. Okay. Now here it says which ones were classified wrong. But again, it measures accuracy, prediction, recall on the training set. Okay. Now you can, if you like, for example, in this case, we'll go and explain each one by one. Logistic regression, for example, can give you a confusion plot on the training data. Okay, and then also it takes 20% of it and creates a validation sample. Okay, that validation sample, let's say confusion plot, again, there's 2 misclassifying inputs, so it'll give you the specificity and sensitivity and percentage correct. Now, if you decide this is what you want to use, you can always come here and say, okay, let's run this analysis. Okay, or let me use these to now predict. In this case, I'm not ready for that yet, so I'll just go back and show you the rest. Similarly for random forest. Okay, the random forest tells you the importance of the variables. Now, different analyses have different, I guess, levels of being able to explain what the input variables represent on the output. Okay. Logistic regression as a good is a good model as explanatory. Okay, as an explanation. Similarly, random forest starts getting better. KN is a bit harder to use to explain what each value is doing. Okay. In this case, as you can see, it's very simple what it does to predict. And then SVM as well, similarly, it's also not great at being used to explain the effect of each column or each variable, each input in the outcome. Okay. And discriminant analysis, this one actually doesn't do a very good job in this case. But she goes and she researches a bit more what each one does and maybe said, okay, I want to use, for example, random forest on this test. I want to be able to use this to explain, to categorize these inputs here. And I can go into machine learning. And you can look at classification regression trees. Okay, you can say, okay, my dependent variable is this case. The one is qualitative, sorry. And my explanatory variables are all these quantities. Okay. Then I have a few things. Now, if you're into machine learning and you work in Python, you probably recognize a few options. No. I could do a validation set. Okay, basically take this 100 different readings and take a random sample of 20. Okay. Then prediction. I want you to predict using these columns, okay, and variables, and I want to use the observation ID as the label, just so I know which one is which. Okay. Again, what to do with missing data? Remember, the other one identified 2 missing data sets. Here's one, row 25. Just remove them. Okay, you can estimate it, but removal is just probably a safer option in this case. And then what outputs I want. And then this is in charts. I want the tree chart. Just click OK. Again, correlations between the variables. Okay. In this case, now it's confusion metrics on the training set. Again, a lot of input, and then this is a categorization tree. So basically, which inputs represent are used to categorize the values. Okay. So this is the validation. This is what the value actually is. This is the 20 bits that randomly picked, okay, to calculate. It didn't use it on the training. And this is the prediction. So it's got a few that are not right. Okay, so it's probably not doing a great job. Okay, so it's like, okay, there's quite a few here that are not right on this validation set. I know what it should be, but this is wrong. So you might say, okay, I want to try another one. Let me see if we can do a random forest. Okay, yeah. Random forest. Now we use this example here. This tree is a single tree. A random forest is just a collection of them. Okay, we'll do a large number of them and then I guess average the output. Okay. So again, we can go and say, okay, data case 3. The response is that. Okay, and the explanatory are these guys. And I can go variable levels. I can do a validation of 20 again. And I want to predict using these values. Now notice that they have to be on the same order, right? So it knows, same data set. And my observations are here. Missing data, remove, outputs. And let's click OK. Again, I keep getting this every time. It's saying, okay, everything's okay. If by any chance you don't click the right information, it will tell you this, for example, there's no quantitative data or there's no sufficient data. Can then allow you to go back and modify the inputs, the selections. Okay. In this case, again, some statistics as always. And then again, confusion metrics for the sample out of 80 or 78, and then the other 20. In this case, again, misclassified is classified 2. And then, but it's better than the other one. Okay. Now a model with a I guess specificity of 90% is actually a good model, given that our data sample is not huge. But the process will be similar for all of them. Okay, there's a few more you can do. Because here we have k nearest neighbors. Okay, and again, it will give you a different outcome. As usual, you can always export to Word, to PowerPoint. I can decide, for example, I can just go. Let me just jump to the top. If I see a report, okay, and I want to run it again, but I can't remember how I run it or what the parameters were. I can always click this button here, and it will give me the input box, okay, the input box on how it was run. Okay, so I can always go back and again change a parameter and get a new example, validation, I can validate with less than them, less observations, and run it again, right? Here it is, and then see how that worked, how that went. Okay, I said, okay, only one is off, but still 90% off, but on. Okay, so you can always go back to that. You can decide now I want to remove the grid to make it look better. Export it. Again, you can always jump different bits and pieces. Okay. Now, notice here, there's a lot of information about when it was some of the parameters that were run. Okay. And if it's in the random numbers, the seed that was used for it. Okay. Just it will change from analysis to analysis. All the analysis will have it. Okay. Just the main parameters used in analysis, so you can always go back, or there's some trace on what data file was used and the variables. So there's always something you can go back to. Okay, so that was the last case I had. Now there's a few things that I want to show you. Okay, in the last 10 minutes. Again, I have some snapshots here that you can revisit. This case random forest and KN, and then you can just compare the outcomes. There's also in the machine learning, there is unsupervised models that you can use, but not for categorization and grouping and whatnot. So there's a lot to play with in the machine learning modules. A few tips once you start using the tool. This, again, I talked about most of this. This is a typical interface. Generated VBA code, click in here. Again, data selection mode is very important because you can either select directly from the worksheet or have the software scan the headings of the columns, okay, or going to the file, load from file into memory mode. Okay, that's the key one. And then the output, whether you want it in another worksheet, another workbook, or a specific column of your workbook. Again, I think I show most of this. Again, finding analysis is quite useful, especially if you don't remember exactly what is located or even the exact name, or when I see things are related to it. So show you now if you go and search for ANOVA, a lot of things will come up that you probably don't know. If you work with KTA data, click all that applied data. There's probably quite a few things that you can do with it. Okay. Okay. Again, coloring. And you can also data anonymize, basically get rid of names, for example, or specific numbers. Exporting. Okay. Jump to a place or export. And then the assistant. I want to show you this assistant because it's quite handy. It's here under the button, under my assistant. Okay. You can go into the Get Started with XLSTAT. For example, it will show you how to import your data. It actually opens the file, and you can click through it, open an Excel file, just walks you through it. This is quite simple, how to open a large file. We did this, so if you forgot how to do it, just go into My Assistant. Okay. For example, we can also, under My Assistant, it can help you run your first analysis. For example, let's do ANOVA. Now it depends on what package, or let's do a KTA analysis. So quite handy. And this is an example, okay, on how KTA analysis is done with a data set. Because data set is how many rows? 714 rows, so it's quite significant, and there's a lot of explanation going on. Selecting the data, which you've done, know what the products, etc., all the bits you run, and then here's the analysis. And it actually does it, or the developers did a great job help explain this. So, what's happening, it's frequency checks, and you can go to the next tab. Again, each assessor make sure they all make sense. And it does a lot of explanation. So multi-pairwise comparisons, and then what conclusion can be gleaned from this information. Okay. So something that somebody working on this industry with this type of data would do. Okay, eigenvalues and inertia. Okay. So a lot of information you can play with. It's also let's see. Let me close that. Let me show you the tutorials. Tutorials are guides and examples on, for example, data visualization, how to the radar chart. And then you can download the data set that walks you through this example. Okay. Now, feature extraction, tutorial, sentiment analysis, term selection. If you, for example, let's click here. Again, there's a data set here, an explanation step by step on how to go about this data set. Okay, and creating a word cloud. So the tool has a lot of, as I mentioned, has a large number of analysis, over 270, and then we keep adding bits and pieces as we get requests from clients.
Thank you so much for this presentation. It was very good, and we got a lot of insights, and I hope that all the attendees feel the same.